Howdy doody. I've been asked to go through example 5, page 19, mostly because the notation's a bit odd here. So I'm going to do this question on another page and just try and explain it myself. They're using a notation that comes from geometric sequence. So this is geometric sequence of numbers. And they've given you a formula to work with here that's Tn plus 1 equals T1 times r to the power of n. It's a little bit confusing that they're using n plus 1, but the reason they're doing that is the first thing that you're going to work out is actually a second term. You're going to make n equals 1, right? If you make n equals 1, you'll be at term 2, and that will be the second amount in the sequence, but it will be after 1 year, right? So n is standing for the number of years for the investment, number of years. These t's mean terms in a sequence. You can imagine I'm putting $5,000 in. This is actually at time 0, and I've written over here that was term number 1. And then after 1 year, I've come along and I've multiplied it by this number. Okay, and I will get some new amount, which will be term 2, right? So hopefully that's obvious in the formula. N equals 1 after 1 year. That will give you 1 plus 1. It will give you a second term. You're going to get that by doing the term 1, which is 5,000, times your R value. Can I fit that in here? Yeah, R equals 1.052. Let's just explain what that is. The 1 is because we want to keep the $5,000. So that's really representing 100% of the 5,000. The 5.2 is because the interest on the money is 5.2%, right? So at the end of 1 year, you're going to work out your new amount by doing 5,000 times 1.052. This is called a multiplier in financial maths. But if you've always done methods, you might not have heard that word used. It's a bit more of a general maths thing. So that would give us some amount. I'm not sure what it is, 5% roughly, plus 5,000. So what's that? I don't know, $5,250 or something. Then you're going to take that amount and you're going to add another 5% in the next year, right? And you'll get your third term, which is coming after 2 years of investment. Then you'll take that and you'll multiply again, and at the end of that year you'll have your interest added and you'll have your fourth term, right? So you end up with this geometric sequence. Graphically, you start at 5,000 and then you earn a bit of interest and you earn a bit more and you earn a bit more and you earn a bit more, and you effectively getting an exponential curve here, which hopefully you can see. It's I don't know what we call that, dollars equals, or y equals dollars, and then x is time in years, where we've used n for years. So when we've got t1 r to the n, that's just like a y equals some number to the power of x, right? And it's just growing like this. The difference technically is that when we're looking at sequences of amounts, you can see the way I've just drawn dots here. So we don't actually join the dots because the interest is only coming at the end of the year, right? But mathematically, you can still think about this as just an exponential growth curve, I think. Now, you'll notice as I'm working out successive terms, I'm doing exactly the same thing. I'm just multiplying by the same thing. We've got a better way to do that. We don't need to keep going times by this, times by this, times by this. We just say, well, we'll use powers, right? Powers are a shortcut for multiplication, right? So hopefully that explains the formula well enough for you. It's a bit messy, but I'm trying to say here that N stands for numbers of years. The T1 means the first term, right? The R value is your common ratio that you're multiplying. For us, it will have to be made up of interest rate plus, and we need the 1 so that we actually keep the money, right? So their question is simply, they're giving you this formula. You know these numbers. This one's 5,000, and that's all you need to know. In their question, they say, how long until we get $20,000, 20K. And what they're really asking there is, what's the N? Right? So this is an unknown powers question which requires logs to solve, unless you want to graph it. So we would say we've got this formula that works out what our terms are at the end of each year. 5,000 times 1.052 to the power of n. I know the n plus 1 thing is a bit confusing, but maybe you can think of it this way. If before you even start, like at time 0, you've already got $5,000, and that makes sense. Like if you make this n 0, you're left with term 1, and your power over here is 0, so this whole number would just become 1. You'd have your 5,000, right? So that's what this n plus 1 is saying. And the formula will work. You don't have to worry too much. You just need to take this and say, when will it be $20,000? Now, I don't think we're going to get a whole number answer, and technically we should make it a whole number answer. I assume the bank's going to say, no, you don't get that interest unless you actually keep the money in for the whole year. I'm not really sure, but honestly, interest is calculated daily in this day and age. So the idea that you have this per annum amount of interest is pretty simplified to begin with. Anyway, all I've done at this point is I've divided both sides of this equation by 5,000, right? So I was left with 4. This is the point where I would bring logs into it. So maybe I'll go over here. Whoa. You can use whatever log you like. I think I'll use log base 10. We're about to use a log law. In fact, I can do it here. I'm sure you can handle this. Right, so I was logging both sides. I had 1.052 to the power of n, and then I've brought the n out the front using log laws. If we want to calculate n, we'll have to do log 4 divided by log 1.052, and at this point we're needing the calculator to do that. Okay, if you're still a bit unsure about that, you can ask me. I'm going to look at the question now and see what they did. Well, yeah, you can see they've done exactly the same thing. They've got 27.3 years. Now, notice that they've done what I thought they should do, which is to actually round it up to 28 years, right? with the idea being the interest, you're only going to actually qualify for that interest if you're leaving the money in for that whole year. So that's why they've rounded up to 28 there. They're saying after 27 years, you wouldn't have actually made $20,000 yet. You would have to wait. Just having a look, wondering if there's anything about the actual interest earned. There's not. Just be aware that this $20,000 is the final value of the investment, right? And if a question asks you about what was the interest, well, that's the difference there, yeah? So normally when this is taught, financial maths, normally we actually use this formula. Final value is the present value times your multiplier to the power of n, right? And this is what we've worked out. Our formula was basically identical to this. We had our term 1, which was our present value, 5,000. We had our multiplier, which was our r, and to the power of n. It's actually the same formula, but using this terminology, it's maybe a bit more clear that you're working out a final value for your investment, and just be on the lookout for if a question asks you about interest, because this formula is not calculating an actual value of interest. If my final value it was 20,000, which it wouldn't be, because it'd be slightly higher than that after 28 years, but let's just say it is so I can do the maths easily, and the original value was 5,000, then the interest earned, capital I, not little I for interest rate, the interest that you've actually earned is 15,000. Okay, I think you know that, but just checking on the terminology just in case you get a financial style question at some point. Okay, let me know if you have any issues with those questions. There's a couple there, 7 and 8. Yeah, I'll leave it at that.